Hello, welcome back. For this video, we will be discussing this integral, the square root of the quantity 1 plus square root of x all over 1 minus square root of x from 0 to 1. For this video, I will discuss a solution where I will turn this algebraic integrand into a trigonometric one. So to do this, what we do is we first realize that the integral or the integrand looks a bit like the half angle identity for tangent and cotangent. So what we will do here is we let square root of x be equal to cosine x or cosine theta. So in a way, that's equivalent to saying that x is equal to cosine squared of theta. And if we do that, we have dx is equal to negative 2 cosine theta sine theta d theta. And then if x equals 0, then cosine theta must be 0 and theta must be pi over 2. And at x equals 1, theta must be 0. So in fact, the new bounds of integration here should be pi over 2 to 0. It should be pi over 2 to 0, but then again, we have a negative sign on the differential element. So we can just cancel that out and switch the order of integration from 0 to pi over 2. Then for the rest, we substitute again x is equal to cosine squared theta. So this square root of x is cosine theta. So this becomes square root of 1 plus cosine theta all over 1 minus cosine theta times the differential element, which is 2 cosine theta sine theta. Right? As I've mentioned earlier, this expression here, the squared thing, is related to the tangent identity. So if we use the cotangent half angle identity, we know that cotangent of beta over 2 is equal to the square root of 1 plus cosine beta over 1 minus cosine beta. So this first radical here is equivalent to cotangent of theta over 2, right? And then I would like also to express this sine theta in terms of theta over 2 angles using the double angle identity for sine. We know that sine 2 alpha is equal to 2 sine alpha cosine alpha. So this sine theta here is equivalent to this orange thing here, 2 sine of theta over 2 times cosine theta over 2. Now I want to do this because I can rewrite this cotangent theta over 2 using the cotangent definition or the cotangent identity. We know that cotangent of an angle alpha is equal to cosine over sine of alpha. So this is equal to this green angle here, or green expression, is equivalent to this blue, which is cosine theta over 2 over sine theta over 2. So note that also I just factored out the coefficient, which is 2 times 2 equal to 4. And now that we have here sine theta over 2 in the denominator and sine theta over 2 here as well, we can cancel them out, leaving us with cosine theta times cosine squared of theta over 2. So we have transformed this algebraic expression here into this trigonometric expression. So now we're only dealing with this trig expression here. So the next part will be evaluating this trig expression. So we have the integral again of cosine theta times cosine squared of theta over 2 from theta equals 0 to pi over 2. We have a square of cosine here, so we can use a power reduction identity to express that in terms of theta. Using this power reduction, we know that cosine squared of alpha is equal to 1 plus cosine 2 alpha all over 2. So this cosine squared theta over 2 is equal to 1 plus cosine of theta all over 2. And then we just multiply out the coefficients for divided by 2. So that's 2 coefficient here. And then distribute this cosine theta. We get cosine theta plus cosine squared theta as a new integrand. Once we're here, we can further use the power reduction identity to express this cosine squared theta in terms of cosine 2 theta. That's similar to this one, the first one we used. So 1 plus cosine 2 theta all over 2. And then we can just evaluate them individually. This is, I think, standard trigonometric expressions. So I believe we can answer this one already. Cosine theta, antiderivative is sine 2 theta, 1 over 2. Antiderivative is theta over 2. Cosine 2 theta over 2. Antiderivative is sine 2 theta all over 4. Okay? We will evaluate this from 0 to pi over 2. So we just evaluate at the limits. The first one becomes sine pi over 2 minus sine 0. This one is pi over 2 minus 0 times 1/2. Then this one is 1/4 times sine of this becomes pi, sine pi minus sine of 0. And then we evaluate this. We get this 1 minus 0. This is 1/2 times pi over 2. 1/4 times 0 minus 0. So that's 0. So we have the answer being equal to 2 times the quantity 1 plus pi over 4, which we can further simplify as 2 plus pi over 2. And that's our final answer. So again, what we did here is we just used several trigonometric identities to re-express the algebraic integrand into a trigonometric one. There are many alternative ways of doing this, but I just prefer this one because I'm quite acquainted with trigonometric identities. By the way, if you're already here in the cosine theta plus cosine squared theta integral, you can actually use beta function or beta integral here, as well as Wallis formula to skip the rest of the steps, right? So if you do that, you'll get the answer as 2 plus pi over 2 as well. Okay, so I'm leaving another exercise for you, which is a bit related to this one. Instead of 1 plus square root of x over 1 minus square root of x, I want you to answer the reciprocal of that, which is 1 minus square root of x over 1 plus square root of x. Leave the comments and your solution in the comment section. And that's it for this video. If you have any questions, clarifications, alternative solutions, or any other things you want to say, just leave them in the comments. Thank you for watching and see you on the next one. Bye-bye.